Greetings everyone, my name is Janet and today I'll be presenting on containerization of application using Docker. Now before understanding what even containerization is, we first need to look at what is the problem that we're trying to solve. So we'll first be covering this problem, the works on a machine problem, and then we'll go on to how Docker saves the day, if there are things that exist other than Docker, and the difference between this and virtualization. So you might have made an app previous semester में or personally या फिर internship में or any project. So you make it. It goes a little complex. उसे files चाहिए, उसे API keys चाहिए, उसे React के complicated बहुत specific version चाहिए. It needs a very specific dependency. उसका version चाहिए. आप बहुत वर्जिश करते हैं. You finally make that app. It works on computer. You're proud of it. And then you go on to show it to your teammates. They are impressed. Demo चल रहा है. But now they also want to run it on their systems. They try to run it, but it doesn't work. Now, how many of you have faced this problem? आपने project बनाया, you show it to your teammates, but it doesn't work on this system. It only works on your system. It works on my machine. This is the problem. Is there anyone of you? Okay, yes. I see very familiar hands. Okay, so the problem could be anything. Missing dependencies, misconfigured systems, missing files, Python path में नहीं है. I've seen this stuff first hand too. बंदे zip करके फाइल एक दूसरे को भेज रहे हैं. डिपेंडेंसी कौन इंस्टॉल करेगा कोई नहीं जानता. Now that you have some idea of the problem that we're trying to solve, this is where Docker comes in and saves the day. So basically what Docker is doing is it's packaging your entire app into something that can be deployed anywhere. You can think of it in this way कि तुम एक इंटरनेट से exe डाउनलोड करते हो, set up for a program, you run it, वो क्या करता है, it installs all the files it needs, specific directories में, sets up the registry keys, maybe path में भी add कर लेता है, you know, जो भी exe काम करता है. If it runs on your computer, set up कर देता है, it can run on my computer, set up कर देता है, किसी भी computer में, it does what it does, and it does it consistently. So this is what Docker is doing, but kind of better. Docker एक image में it packs everything your app needs. तुम्हारी files it would need in the order in which it would need, the environment variables and all the dependencies, specific versions के साथ, यही सब कुछ. And what happens is then if ये सब करने के बाद your app works perfectly in your container on your machine, it can anywhere जहाँ पे भी Docker run कर सकता है. This leads me to my next point कि Docker provides a very consistent environment. Consistent as in Docker can run on Mac, Windows, Linux. तो अगर तुम जो container तुमने बनाया है, if it can run in Linux, it can run on anywhere where Docker can run. So this is the benefit जो Docker दे रहा है. It's very consistent. You don't container बनाया, you don't have to worry about anything else. And adding more to that, Docker also does it in a way कि जो तुम्हारे containers होते हैं, they like isolated. How is this helpful? मान लो one of your container या फिर host system पे malicious code run करने लग जाता है. It tries to kill every process it can, but the way Docker does its isolation वाली thing, it does it in a manner कि कोई और process Docker वाले process को touch नहीं कर सकता, और maybe Docker का एक container का process दूसरे container का process को के साथ communicate नहीं कर सकता. They like isolated, they can't see each other. So Docker provides isolated environments इस way में, and this is very helpful from a security point of view. And due to the way Docker does everything, ये बहुत ज़्यादा fast way में deploy हो जाता है. Like you can spin up a container in few seconds compared to a virtual machine जो time लेता है allocate होने में, फिर start होने में. Docker में it's very fast, and due to it being very fast, तुम इसका फायदा उठा सकते हो in the form of automations. Like there's things like Kubernetes जो multiple computers पे cluster run करता है, and then it can maintain कि कितने containers चाहिए. I have an analogy for that. मान लो we guys are crypto mining आपस में Kubernetes के cluster में. We have an image वो deploy कर रखी है. So we have अक्षर का computer, आयुष का computer, श्रेयांश का computer, इन पे nodes चल रहे हैं. And then backup में we have mine, Devang and यश के computers, वत्सल के भी computer. So if Shreyans का node goes down, उसका computer फट गया, Kubernetes sees that कि oh no, एक node चला गया, हमें 5 node चाहिए, तो it would see कि उसके पास और extra nodes है and it would spin up new containers fast, जल्दी to maintain जो हमने specify किया account. So ऐसे automation पे use हो जाता है, right? So now of course, Docker isn't the only containerizing tool in the industry, and thankfully we have standards. जैसे PCs में standards होते हैं कि you have a motherboard and you have a CPU. CPU का जो एक specific socket है, अगर motherboard वो socket support करता है तो कोई भी manufacturer का motherboard हो वो उसमें चला जाएगा. We have standards for that. Same फिर कि motherboard का specific size की है and we have a case इस specific size का, तो फिर motherboard उस case में fit हो सकती है. This is all working due to standards. So fortunately, we also have standards in containerizing industry, and this is all done by this organization called OCI, Open Container Initiative. This is run by the Linux Foundation, and it defines सारे standards कि एक container में क्या होना चाहिए और जो container का जो image होता है उसमें क्या होना चाहिए. It defines all the specifications, and then different organizations can implement their own container runtimes. जैसे we have Docker, उसका खुद का runtime है, and then we have Podman, उसका खुद का runtime है, and then we have Kubernetes जो इन सब को use करता है to do its own thing. So इससे होता क्या है, you make an image Docker के अंदर, उसको you can deploy it फिर Podman में, जैसे वही Docker image you can deploy it in Kubernetes. तो इससे होता क्या है, images made in Docker can be run in say Podman or say Kubernetes. तो you can think of it in this way. तुम C++ का प्रोग्राम बनाते हो, you compile it on your system. जो build exe फाइल होती है, it can run anywhere, Windows 7, 8, 10, heck even Linux में भी चल जाएगा if you set up emulation वाला part correctly. It's kind of like that. Docker के image Podman में चल जाएगी, Kubernetes में चल जाएगी. This is all doing to prevent this is thing called vendor lock-ins. जैसे if I take the example of Dell के pre-builds और HP के pre-builds, what they do is like I was talking about motherboards और computer cases के standards होते हैं. तो what these guys do is उनके कुछ pre-builds में they use their proprietary their own motherboards, उनके custom sizes. तो अगर तुम्हारे पास उनके computers हैं and if you want to upgrade something, तुम्हें अपना case change करना है or you want to replace your motherboard, you can't do that because they're like completely disregarding the standards. If you try to do it, तो फिर there are not many products out there जो वो support करते हैं, so you kind of locked into Dell or HP के उसमें. So what you eventually end up with is a stinking pile of e-waste. This is the problem that standards are trying to solve. Alright, so now if you've done stuff virtual machine के अंदर, you might be wondering what even is the difference between Docker and say a virtual machine. They both isolated processes, yes, but the obvious difference between them both is Docker container में it can use as much resources it needs जितना host computer पे available है. Like मेरे पास 8 GB RAM है, 4 cores है. If a container needs it, it can use as much as that. सारे containers में option है. But inside a VM, you might have seen it too. You have to specify उसे कितना RAM देना है, उसे कितना CPU देना है. It's constrained by the actual limits you can specify. तो तुम ये containers में भी कर सकते हो, but VM में it's more like very strict. Containers are flexible. This is the surface level difference, surface level overview it. So हम थोड़ा सा detail में आ जाते हैं. So whenever you get around to learning containerization and virtualization में difference, this is the diagram everyone will show you, everyone will teach you. तो इसमें हो क्या रहा है? You have this first layer, infrastructure. Think of it as your computer, but remove the OS part of it. अब क्या बचा? Just raw CPU, memory, yep, that stuff. That is the infrastructure. So in your computer, infrastructure के ऊपर you have operating system. That is how you can use it. But in enterprise servers, what they happen to use is a thing called hypervisor. A hypervisor is a virtual machine manager. You might have used VirtualBox या फिर VMware to make virtual machines. Hypervisor भी वही कर रहा है. But the difference between them both is VirtualBox and VMware, they both sit above the operating system level, to make virtual machines. That kind of slows things down. You might have noticed as well. Performance इतना चाहिए उस पे gaming try करोगे it won't work. But hypervisor में क्या difference है? जो भी उसमें virtual machines बना रहे हो, it offers them the same performance to them as if they were running natively on that machine. जैसे we have Windows machine running, यहाँ पे Linux का VM चल रहा है. दोनों जो भी लिमिट स्पेसिफाई करोगे they would get the same performance अगर वो natively उस पे इंस्टॉल होता है, like OS में जैसा होता है, like as if they were installed on that hardware as an operating system. They get the same native performance. This thing is called bare metal performance, and hypervisors में यही होता है. This is the difference. On the container side of things, you will see we have a container engine. That container engine is responsible for isolating जो भी container के process है, so they can't interact with one another. But now if you see VM वाले side में hypervisor के ऊपर we have guest OS वाला part, but वो containerization में तो है नहीं. So what is happening here is, जैसे कि Docker का example लेता हूँ, it uses some Linux magically to isolate processes. तो फिर वो क्या करता है, VM में तुम्हारे पास एक Linux की मशीन हो, दूसरी Linux की virtual मशीन हो, अलग OS में इंस्टॉल होते हैं. They both separate, they both completely virtualized. But Docker में, containerization में, because they're all Linux, तो फिर what happens is जो भी core operating system binaries होती हैं, the core operating system that it needs, it all वो तुम्हारे host operating system से ही run होता है. इस कंटेनर में जो उसे फाइल्स चाहिए होंगी ऑपरेटिंग सिस्टम वाली से उसे ls रन करना है, it would use that ls from the ls in your operating system. So Docker is kind of using that magically. जो भी core files हैं, it kind of links them to your main operating system, and then उसके वो करने के बाद तो सारी कोर फाइल्स को योर मेन ओएस पे लिंक करने के बाद इट काइंड ऑफ आल्सो मेक्स देम आइसोलेटेड. तो यहाँ पे अपना डॉकर वर्चुअलाइजेशन का इफेक्ट अचीव कर पा रहा है. वेयर एज इन द वीएम कंप्लीटली आइसोलेटेड, कंप्लीटली वर्चुअलाइज्ड, कुछ शेयरिंग नहीं हो रही. तो दिस इज द कोर डिफरेंस बिटवीन देम. डॉकर इज काइंड यूजिंग सम इल्यूजन काइंड ऑफ थिंग टू क्रिएट एन आइसोलेटेड प्रोसेस. वीएम में इट्स ऑल वर्चुअलाइज्ड. And this is also the reason why Docker के containers are like very easy to spin up, and VM में it's not. VM has to create the entire thing. Docker में it uses what it needs from the host operating system. I hope you learned something. I hope you liked it, and